So before we start talking about how to program the lighting console, I thought it might be a good idea to talk about the physical characteristics of the fixtures that we're going to be controlling, so you have a better idea of what the lighting console is actually doing and how we're getting lighting on the stage itself. So this video is more about describing what the types of light fixtures they are and how they function in relationship to that lighting console. So basically, when we're talking about theater lighting, there's basically two types of fixtures. We have conventional and we have intelligent. Conventional fixtures are just like a lamp that you have at home. It's got a bulb in it, it's got a power cord coming out of it, and you plug it into the wall. So there's a bulb, a reflector, and a lens on a conventional theatrical light fixture. There's a power cable coming out of it, just like you would have a power cord coming out of your light at home. The conventional fixtures are controlled by a dimmer rack. So just like home, you would have a dimmer switch on the wall that would adjust the brightness of that lamp. On the stage, we have a dimmer rack that has multiple dimmers in it that's actually going to control all the different conventional fixtures that we have. And each of those conventional fixtures only uses one DMX channel. We're basically controlling intensity, which is the brightness of the light. Basically adjusting the dimmer up and down to decide how bright the light is going to be on the stage. For a conventional fixture, in order to get color on the stage, we need to insert what we call a gel frame in the front. So there's actually a slot in the front of the fixture where you can put in like a metal frame that will have colored plastic in it. The name gel comes from old Sting's language, but they've always maintained that. But it's basically a piece of translucent colored plastic that we can shine the beam through so we can get various colors. One thing I wanted to note is that in these conventional fixtures, you're using somewhere between a 500 watt and a 750 watt bulb. So they get very, very hot. You don't want to touch them unless you absolutely have gloves on. It's one thing you have to be careful of if we are aiming, which I don't think you're going to be involved in, but I know if I'm up actually aiming lights in that, and they have been used recently and they're on, they're going to be very hot. So I did mention that. Here's an example of some conventional fixtures. This top one here is going to be what we call an ellipsoidal. That's the most common type of fixture. This creates a circle of light on the stage. I think that's what you'll predominantly find at the school. There are some other types though, a par lamp and also a Fresnel. The par and the Fresnel basically create what we call washes, wider areas of light across the stage. And a lot of times they'll put a colored gel frame in these to create a sense of maybe the stage has got to be, it's a nighttime scene and we want it mostly kind of a blue color. So you'd use a par lamp and put a blue gel in there. So it kind of creates that sense of nighttime, giving everything a blue wash across the stage. The Fresnel's is kind of similar. Only difference is with the Fresnel lamp is you can actually focus it a little bit by sliding the reflector inside the lamp itself. But these are all types of conventional fixtures. Conventional fixtures do need to be plugged into a socket on the light bar. The plug is going to look a little different from the plug that you would have on a lamp at home. And generally there's two types of plugs. There's a 3-pin stage plug that looks like this, or it's a twist lock plug. Depending upon whoever the manufacturer was that installed the lighting rig at the school will determine whether we're using 3-pin plugs or whether we're using twist lock plugs. But it's the same idea as a plug on a lamp at home. You plug it into the socket and now you have power going to that light. As I mentioned, that the ellipsoidal is the most common type of conventional fixture, and there are some parts to the ellipsoidal lamp. Back in the back here you would have your bulb and your reflector, so if we've got to change a burnout bulb, we'd access that through the back. The yoke is the bracket that holds the light up and fastens it to the light bar, and it allows us to tilt and swivel the lamp so that we can aim it to various places on stage. Shutter blades, we're actually able to move these in and it will change the shape of the beam from round to square, or we can like close off certain parts of the beam so we can isolate it rather than just having an open round beam. We can isolate it and bring those down. Think of it as being like shutters on a camera. They stay in permanent. We adjust the size and shape of the beam and it would stay that way. The barrel and the front lens here, the barrel actually moves in and out to focus this, so we can have a sharp circle of light on the stage that has a well-defined edge, or we can slightly unfocus it by moving the barrel so that it's a less focused circle of light so that it would blend a little bit better on the stage. And then the lens itself actually comes in different sizes. A 10-degree lens would create a very small pool of light on the stage, whereas a 36-degree lens would create a much larger pool, and even a 50-degree lens would create an even larger pool of light on the stage. Depends on what you're using these for. If you're going to spotlight a very small area of the stage, then you're going to use like a 10 or a 19-degree lens. If you're going to just kind of light a larger area of the stage, then you're looking at 26-degree, 36-degree, or 50-degree, because that's going to light up a much larger area of the stage. Gel frames, as I mentioned, are used to change the colors, and they'll just look like this. It's a metal frame, and then you slide this translucent plastic into it. There are many, many different gel colors, and that's something that we'll discuss in another tutorial, and we'll probably talk about that when we're designing lighting for the show. It all has to do with what kind of a mood that we're trying to create on stage. Is it nighttime? Is it daytime? What kind of costumes are the actors wearing? What are the colors in the costumes? What about the set pieces? And the gel frames can drastically change the look of those things on stage. Change the look of the costumes, change the look of the scenery, etc. Also change the mood. Is it nighttime? Is it daytime? Is it afternoon? Is it inside? Is it outside? So we'll talk about that, but that's how we change the color of the light beam using gel frames on the conventional lights. Now also, we can insert what we call a gobo into a conventional, and these actually place patterns. So if you've ever paid attention when you're outside and it's a really sunny day and you walk under a tree, you can see shadows from the leaves on the ground. Well, we can artificially create those shadows on the stage using what we call gobos. It's actually a round piece of metal, very, very thin, like sheet metal, with a pattern cut into it, and it's inserted into this gobo holder and inserted into the ellipsoidal light, so it actually projects this pattern onto the stage. So you can create this artificial effect of shadows from trees or light coming through a window. It's something that helps us to enhance the overall mood and draw the audience into the stage, where we're creating shadows from leaves or light coming through a window, etc. And we can do that with gobos. Now, intelligent light fixtures are much more involved. Some of the intelligent light fixtures can have a bulb and reflector and a lens like the conventionals do, but a lot of the newer ones now use LEDs in them. They do have a power cable and a DMX cable, but they are not controlled by the dimmer rack. So with an intelligent fixture, you're actually going to supply power to it, but it also gets instructions directly from the light board. And it has many, many DMX channels. As we mentioned, the conventional light only uses one DMX channel because you're just controlling how bright or how dim the bulb is. With an intelligent light fixture, you're controlling a lot more things than intensity. And in general, the intelligent light fixtures do not need a gel frame to create color on the ground. And also, whereas a conventional light fixture is, we aim it and it's in that position for the entire show, an intelligent light fixture can also be a moving head, where the entire light fixture can twist and tilt up and down. We call that pan and tilt. So it can point to different areas of the stage. So it can be very useful because you're not locked into one stage position. It can move around and point to different positions on the stage. They can also have a lot of moving parts to them. Now, intelligent light fixtures do need to be connected to a power source and a DMX cable. I have a picture here of a moving lamp, and you can see on the back of it, our power source is connected in here, but then we're also communicating directly from the light console to this lamp. And we're going to either use 3-pin DMX cables or 5-pin DMX cables. These cables look a lot like microphone cables. Internally, they're a little bit different though, but they send a signal out directly to the fixture to tell it what to do, what color, what gobo to display, possibly to zoom in and out, what position to point to on the floor, etc. It gets all that instruction from the lighting console going directly to the fixture itself. I just put some examples in here. Here's a typical LED par lamp that's going to act as kind of a stage wash. And this particular par lamp here has some different colors to it. It has red, green, blue, and white. This particular one uses 8 DMX channels. That's 8 channels of information that are being controlled by the lighting console. So this lighting console is telling it how bright the red, green, blue, and white LEDs should be, and then overall the dimmer, how bright the fixture should be overall, and then also some extra things like should it flash, should it strobe, and then there's some other things like lighting macros where you can have the light go through a series of color changes on its own, and then the speed of those macros. So a lot more information is being fed into this light then. In this case, it's 8 channels: red, green, blue, white, dimmer, strobe, macros, and macro speed. Here's another example. Now this is a moving lamp, so this is going to have a lot more information being sent into it because we have a yoke that actually moves, so the light can pan, which is spinning side to side, and it can tilt, move up and down. So you're able to point this to different positions on the stage. This particular fixture here uses 16 channels. So we have pan and tilting, the moving, and then the speed of that pan and tilting, the intensity, which is how bright the light is, the focus, so as we're moving to different areas of the stage we need to refocus the lens on there, the iris, like how big it opens and closes. So if you remember on the conventional we use shutters. If this has an electric shutter on it, we can change that. The zoom, where we can change actually the size of the circle on the stage. With the conventional, we're limited to a certain lens. With these, you can zoom in and out, so you can change it from a 10-degree light circle to possibly a 45-degree light circle. A color wheel, so instead of using gels, it actually has a wheel inside the light with a variety of gels that we can instruct the light to put this particular color of gel up and change the color of the light beam. Gobos, instead of having one gobo that you insert into the conventional lamp, we'll have a gobo wheel with a series of different patterns on it, and we can designate what particular gobo is going to be up at what particular time. And actually some of these gobo wheels are fancy. Not only can the gobo come up, but it actually can rotate while it's up in position, so we can control gobo speed. We have prisms in there in this case where it can take the image and split it out into 3 mirror images, and that's what the prism would do. And these mirror images can be rotated, so we have a prism rotation. And then on top of that we have effects that the light can do on its own, and the speed of the effects, and then a reset. So when you're using a lamp like this, it uses a lot more DMX channels involved. So each one's using 16 DMX channels. You can imagine using a series of these lamps would use up a lot of your information coming from the light board very, very quickly. And this is just a picture. If we were to take the covers off that fixture that I'm just showing you, you can see that there's a lot of mechanical stuff going on the inside of this lamp. Here's the color wheel with all the different colors of gels that it has. Here's the gobo wheel with all the different patterns of gobos that it can display. Here's the prism wheel. A lot more operating parts in this, and of course because of that these lamps are a lot more expensive. Your conventional ellipsoidal lamp would be probably around $300. An intelligent light like this, you're probably talking minimum of $2,000 to $3,000 and up from there. Many of them can go $7,000, $12,000 per lamp. So it's a lot more expensive to have a light like this in your rig. Now, the electric bars. Light fixtures are attached to a bar that's above the stage, and the general name for it is called electric. Sometimes we just call them a light bar. In the case of your school, you'll also have a light bar mounted up in the catwalk, which we typically call that front of house because it's in front of the stage. So we call that front of house, and that shines down on the stage. And then above the stage, there should be more light bars with lights that are attached to those light bars. And then generally we call them electrics because they supply the electrical power to the lamps. Up on the bar, there will be 3 types of connections. You're either going to have the dimmer rack connection for your conventionals, or you're going to have a power supply and a DMX connection for your intelligent lights. So there probably will be 3 different types of connections up on that light bar. Dimmer, power, and DMX. Now this is an example of how the conventional lighting fixtures actually work. So somewhere on stage there's going to be what we call a dimmer rack. It is a rack with a whole series of dimmers in it. In this particular rack here you can see that there are a number of dimmers, and each one of these dimmers actually controls 2 sockets up on the light bar. So The lighting console sends a signal to this dimmer rack and tells it how much energy to send to a particular socket on the electric bar. And the sockets will be numbered so that we can tell what dimmer corresponds with what lighting socket up on the light bar. So it's a very, very simple system then. The lighting console sends a signal to the dimmer, tells it how much power to send to the light, and then the conventional light is just plugged into a certain socket. Just have to know what lights are plugged into what sockets so that we can tell what dimmer is actually controlling that light. Now with an intelligent fixture, they do not need the dimmer rack at all. They're just getting standard power going to supply power to the light, but then they're also getting DMX information directly from the light board. So there'll be two cables on there, a standard power source cable, which I did in black here, and then of course your DMX cable that I did in red. That's the information that's coming directly from the lighting console to activate different attributes in that intelligent fixture. So here's our console, and again this will be controlling all of the fixtures, both the conventionals and the intelligents. And it's basically a computer with special keys and faders built onto it that makes it a little bit easier to program, but at heart it is basically a computer that's sending signals to the dimmer rack and directly to the intelligent fixtures. Now, the language that it uses to send the signals is called DMX, which stands for digital multiplex. The information is sent out over a DMX cable. Now, in recent days, because of advances in technology, it used to always be DMX cable, but nowadays you may find some that are sending out the DMX information over Cat5 or Cat6 cable, and even Wi-Fi. Some of the newer fixtures that are coming out have built-in Wi-Fi. The lighting console with a Wi-Fi attachment on it can send DMX information via Wi-Fi up to the light, so now we totally eliminate the cables. That setup makes it a lot easier because now we only have just a power cable and it's getting Wi-Fi information. I'm thinking at the school though most everything is going to be connected by DMX cable since it's a little bit of an older system. So here's the idea. Here's our lighting console. It's sending out DMX signals via a cable to the dimmer cabinet, and then the dimmer rack is actually sending out actual power to these conventional fixtures to determine how bright they are. Now, the lighting console is also sending signals out directly to the intelligent fixtures and basically controlling what they do, what color, what position, zooming, irises, those kind of things, depending upon how many features your intelligent lights have. So the console is sending signals out to both types of fixtures. To understand a little bit about this DMX language, it's digital multiplex, and it allows the computer to control light fixtures, panels, and dimmer racks. When we talk about DMX, you'll often hear the term universes. One universe of DMX is 512 channels. So in other words, one universe of DMX being sent out can control 512 different channels of information. Now, if you remember, that one intelligent light used up like 16 channels. So if you start using a lot of those intelligent lights, you can very, very quickly use up those 512 channels of communication. And I mentioned that here, that some of the intelligent lights may use up to 40 channels or more. And when you watch a large TV show like America's Got Talent, with all the lighting and the LED panels and everything they're using, they're easily using more than 100 universes of DMX or 51,200 channels of information, if you can just imagine that. Each DMX channel itself is divided up into 255 increments. So when a channel is set at 0, it basically means that that attribute is off. So a DMX channel controlling intensity set to 0 means that there would be no intensity. If we set it at 255, that would be full intensity. So that light is on as bright as it possibly can go. And if we were to set it at 127, that's approximately halfway. It's kind of a weird system. You would wonder why it doesn't go from 0 to 100, but it's the way that DMX is set up. It's 0 to 255. So if you're looking at something on the console and the console is displaying it in DMX terms, you'll see that the increments are from 0 to 255. Although we do have the option on the lighting console of displaying DMX values in terms of percent instead of raw DMX values. So a DMX value of 127 would show up on the light board being 50%. And that's what you're going to see on our light board. When it says something is at 50%, it's at 50%. It's actually showing percent values. It's not showing actual DMX values. But I just mentioned this because sometimes in the future you may be working with a light board that's actually displaying DMX values and not percent values. So a DMX value of 179 would be 70%. So when you see a light board saying it's putting out 70%, that's a DMX value of 179. As I mentioned earlier, the DMX signal can be sent out over DMX cables, Cat5, Cat6 cables, or Wi-Fi. And there's different types of cables. Here's a 3-pin DMX. As I mentioned, it looks a lot like a microphone cable, slightly different as far as what the wires are inside and the way that they're insulated. Here's a 5-pin DMX, which you're going to find out on the back of the light board. There is a 5-pin DMX connector. On some lights you will find a 3-pin DMX connector, and there are converters that you can use to convert from 3-pin to 5-pin and 5-pin to 3-pin. So if you happen to buy an intelligent fixture with 3-pin connectors on it, you can buy a converter to convert it from 5-pin to 3-pin. And then of course your Cat5 is your standard computer cable that you would use for a computer network. One last thing before we finish this, and this is important, if we're talking with the director or communicating with actors, or if you're getting instructions from the director, it's important to know when they're talking about various areas of the stage where they want lighting to be. So we always look at this stage areas in the terms of the actor. So if you look here, this is upstage, this is up on stage, and this is the audience. So if you're the actor standing on stage and you're turned around facing the audience, this would be on the actor's right, so that's called upstage right. This would be on the actor's left, which is upstage left, and if the actor's standing in the middle, that's called upstage center. Again, from the actor's perspective, if they're standing in the middle of the stage, this would be stage right, stage left, and center stage. And then if the actor is standing down on the front of the stage, which we typically call the apron, this would be downstage right, downstage left, and downstage center. As lighting people, we have to remember that we're looking at the stage from the audience perspective. So when the director says, could you give me a little bit more light upstage right, remember that that is the upstage right for where the actor is. So that they're asking for more light here. It's not our right, which is the way we're looking at the stage. We always have to refer to this as the actor's perspective. So upstage, center stage, downstage, right side of the stage, left side of the stage, and center side of the stage. This will just help you when you're communicating with the director and we're trying to be on the same page as where are you talking about having more light and what we can do with the way that we're programming our lighting. That about does it for now. We'll have some more tutorials coming as far as actually how to program the light board and understanding some of the controls on the light board itself.